Okay, this video will complete section R.5. We're going to talk about a technique called completing the square. This is something that you will use a lot when we get to our conics of parabolas and circles, and some other places prior to that. The idea behind completing the square is to turn a polynomial into a perfect square trinomial. So we've already talked about a perfect square trinomial and how you recognize them, but now we're going to talk about how you can force it to be one. Okay, so we want to identify the coefficient of the first degree term, which is b. So in a trinomial, let's look at this example here. N is to the second power. It's the second degree term. Here, in the next term, 10n, n is to the first power. It's our first degree term. So 10 would be b in that example. That's what they mean by that. Then we'll multiply this by 1/2 and then square the result. And then if you're working an equation, which we won't be doing yet here, but we will eventually, we're just setting it up now, then you have to add it to both sides of an equation. But if we're just setting up a perfect square trinomial, we'll just add it to the two terms we already have here. Okay, let's look at a few examples. We want to determine the number that must be added to this expression to complete the square, to make it a perfect square trinomial, so that if you factor it, the factored form will be a binomial squared. Okay, so let's look at n squared plus 10n. It says we want to identify the coefficient of the first degree term, and as I just said, the first degree term is n to the first, so its coefficient is 10. We've identified that. We want to multiply it by 1/2, square the result, and then it says, what are you going to add? Okay, so we're going to take 1/2 times the 10 and square it. So what are we adding to this? Well, what's 1/2 of 10? 5. What's 5 squared? 25. So what's our result? We would have n squared plus 10n plus 25. And if you recall, what we said the steps for recognizing a perfect square trinomial is the first and last terms have to be perfect squares, and the middle has to be equal to 2 times a times b. Well, what's a? It's 1. And what's b? This is b squared, right? So what would b be? It'd be 5. So 1 times 5 is 5, and then 2 times 5 is 10, right? So that's a squared and that's b squared, and this is 2 times a times b, just the numbers there. Okay, so how would that factor? Well, we know if it's a perfect square trinomial, it's going to be a plus, because that's plus, b squared. Perfect square. If we write that twice and FOIL it, we'll get this. Okay, let's try that again. We're supposed to identify the coefficient of b of the first degree term. There's the second degree term, there's the first degree term. It's -16. So -16, then we multiply it by 1/2, and then we square that entire result. So 1/2 of -16, -8, -8 squared. It will always be a positive, won't it? Because once you square a negative, it's a positive. So we're always going to be adding. That's why it doesn't say subtract, just add. Okay, so we have x squared minus 16x plus 64. So a is 1 here again, but b is 8. Remember, that's a squared and that's b squared. So b is 8. So it's going to be a, which is 1x, plus b squared. Whoops, is it plus? No, because that first sign is negative, right? So when we FOIL, we want to get -16x. So x minus 8 squared. Write it twice and FOIL. This is what you should get. Perfect square. Okay, last one. Identify b. It's 7. That's the coefficient of the first degree term. Multiply 7 by 1/2. Not quite as pretty as what we've been seeing. Square. Well, what's half of 7? Let's don't use decimals. We're not going to use decimals in college algebra unless it's a application problem and decimals are called for and we're given rounding instructions. So this will be a fraction. So half of 7 is 7 over 2, 7 halves. And if you square 7 halves, you square the top. 7 squared is 49, and you square the bottom, and you get 4. 7 over 2 squared, 49 over 4. So the result, z squared plus 7z plus, and this one was a plus, 49 over 4. Now, how does that factor? Ooh, that looks crazy. I got to factor this thing. But that's a perfect square trinomial. So it's just a plus, and what was b? What did we square right there? 7 over 2. So notice every time here our b was 5 and there's the 5. Our b was 8 and there's the 8. It was actually negative 8. And our b was 7 over 2 and there's 7 over 2. So the factoring is really easy. It's just a and b. What's the square root of 49 over 4? 7 over 2. Square root of 64. And it would have been negative because this is negative. Square root of 25. Okay? All right, that completes section R.5.